Let's see if the DI method is something that you would like to use when it comes to integration by parts. I'm using an example from the problem set here. Easiest way to learn the DI method is to look at an example. So to do the DI method, we need some rows and columns, which we mark with S for sign, D for derivative, I for integral. And then each row get alternating plus and minus. So then we look at these two terms, which is easiest to integrate? Well, clearly e to the power of x, because the integral of that is just itself again. So x plus 1 goes in the derivative column. Then we take the derivative of x plus 1, which is 1, and here we still have e to the power of x, and when we take the integral of that. Then the derivative of 1 is 0, and still e to the power of x in the integral column. Now we reach the stop condition. So we see the 0 here, that means that we stop. Then we take the diagonal. We multiply the diagonals. So x plus 1 times e to the power of x. And then we look at the next row. Here it says minus 1 times e to the power of x. And now we can simplify this expression. So what we're left with here is x. Now we solve the first question. Let's go for the next one. I almost forgot. Plus c. We need some rows and columns. S for sign, D for derivative, I for integral, plus minus. Which is easiest to integrate? Well, 2y seems easier to integrate. Put that there. The derivative of ln y is 1 over y. And the integral of 2y is y to the power of 2. Now, we are not going to get the 0 here in the derivative column anytime soon. So there's another stop condition, and that is this row is easy to integrate. When we see a row here which is easy to integrate, we can also stop. The first stop condition was it was 0. Now the second stop condition is that it's easy to integrate. There is actually a third stop condition also, but I don't know about that, and I think it only applies to trigonometric functions. Anyway, we continue with the diagonal multiplication. So ln y times y to the power of 2 minus, because there's a minus sign here, the integral of 1 minus y times y to the power of 2. And then we can see that these two cancel out, so this actually becomes just y. Then we actually do the integration here also. So the integral of y is y to the power of 2 divided by 2. And then we can simplify this because we can factor out y to the power of 2 plus c. Now we have solved the second one. Let's go for the third one. Now it's this interval here from 0 to 1, but let not that be an obstacle, because we're just going to do the DI method again. Sine, derivative, integral, plus, minus, plus. Easiest to integrate is e to the power of something, so we put that here. So the other one goes here. 4 is the derivative of 4c, and e to the power of minus 2z is the exponent here slides down. Then the derivative of 4 is 0. So now we reach a stop condition. Just going to take the derivative of the antiderivative of this one also, the integral. So minus 2 slides down. And then we see that these two multiplied by each other is 4. So now let's take the diagonal multiplication. So 4c times this term. And then we look here, the sign is minus. And then 4 times this term, the diagonal multiplication. And then we simplify this expression. So now we have the integral here. So let's calculate the value also of this integral from 0 to 1. From 0 to 1. So we take this expression here. Put everything in parentheses. And then we plug in 0 and 1. All right. We can take this whole expression and calculate the values now. So this is just minus 2. This is minus 3, right? This becomes 0. So e to the power of 0 is 1. This becomes 0. So 0 minus 1 is minus 1. And then if we remove some parentheses and stuff, we can write this as minus 3 e to the power of minus 2 minus 1 times minus 1, so it becomes plus 1. Have we done it correctly? Well, on the exam, a non-programmable calculator like this one is allowed, they have said, and even the programmable might be also allowed if we have cleared the memory in it. Anyways, it's good to know this button on the non-programmable allowed calculator. So here we can type in this function. For C, I have used x instead. E to the power of minus 2x from 0 to 1. Let's calculate that. We get 0.593 and so on. Then we try our expression. Minus 3 times e to the power of minus 2 plus 1. We see that we get the exact same number. So if we look what it was before, it's exactly the same number. So then we know that we have done it right. This is a way to check your own calculations. So this was integration by parts with the DI method and a little checking of if we have done it right using this button on the calculator.